So last time we were in the middle of something. I believe it was the average age of I called mu s to be the average age of sophomores or juniors. Sophomores, and that was mu1, correct?
1.
That's the best it could do. This was mu1. And mu sub j was mu2. And that was the average age of juniors. The goal was to find the confidence interval for the difference in means, which is mu1 minus mu2. And to that end, we collected a sample, and sample 1 and sample 2. Sample 2, sample 1 was for sophomores, and sample 2 was for juniors. And what is the information that we got from the sample? We found x1 bar, and what is the finding? Gina.
It's X bar for sophomores. 19.07.
The standard deviation,
0.494.
the sample size,
13.
13. X2 bar,
20.417.
we'll call it 42. S2,
1.564.
sample size,
12.
12. So this is what we had from the sample. We collected 2 samples, sample 1 and sample 2. And we put this in the calculator, and 19.07, 0.494, and 13 are the respective mean, standard deviation, and sample size. Same over here for the second sample. Then we went and found the standard error. And what is that? It is the square root of s1 squared over n1 plus s2 squared over n2. When I did this calculation, I was saying, oh, the answer has to be about 0.4 something. But Caitlin, not here, another person said, no, it is 0.22.
Yeah, but we didn't do the square root.
because they didn't do the square root. So to correct that, the answer has to be 0.4 something, 0.48,
0.471.
0.471,
It was 0.4705.
okay, 0.471. The next objective is to find the margin of error. If we find the margin of error, then we can find the interval. The margin of error A is always a product of two things. What are the two things?
Critical value and standard error.
It is the critical value and standard error. So we computed the standard error already. We just have to find the critical value. So what should the critical value be? To get the critical value, we need to know the distribution. The distribution is t, and anytime we have a t distribution, what should we know in addition to knowing that it is just a distribution? We need something else. Degrees of freedom. Now, how do we find that degrees of freedom? That sort of is tricky in this case, since we have n1 and n2. If we simply had n1 or just n2, then the degrees of freedom would be n1 minus 1. That's what we did with the simple t-test. Since we have two different samples and two different sample sizes, the degrees of freedom would be the minimum of n1 minus 1 and n2 minus 1. Now this is one of three approaches, so I'm going to do this and then I'm going to do another case and then the last case would be the most accurate one. So n1 in this case is 13, so 13 minus 1, 12 minus 1, which would be the minimum of 12 and 11, which is obviously 11. Good so far? Now, you should know this by now. How do we find the critical value? T-test?
Or whatever the test statistic is.
We're not doing a test.
Oh.
So there should be no test here.
Inverse norm?
Inverse norm? Did I use the word norm since I started class today?
Inverse t.
Inverse t. So you find the critical value using inverse t. If you don't have inverse t, what do? Abort mission. Still haven't answered my question. Use the table. last time we had a value of alpha. What is the value of alpha? Was it 0.05?
You said 95%.
Yeah.
So 95% confidence. If the amount of confidence is 95%, alpha is 1 minus 95%, which is simply 0.95. Which would give us 0.05. We're talking about an interval. So an interval has two sides, do you agree? A smaller value and a larger value. And when we say interval, possible values lie between the minimum and the maximum, or the lower bound and the upper bound. So, in other words, when you perform or when you try to obtain a confidence interval, we are actually following what we would do with a two-tailed test. So, with the two-tailed test, the rejection region is on both sides. So what do we do with the alpha?
Divided by 2?
Divided by 2. So I'm going to write T 1 minus alpha over 2 to indicate the area below. So the area above is simply 0.05 divided by 2, which is 0.025. If the area above is 0.025, what is the area below? It is 1 minus that value, so we would have T 0.975, comma, the degrees of freedom, which in this case is 11. So that is going to give us the positive critical value. Since the distribution is symmetric, we can find this and multiply it by -1. Or, if you want to try this, to verify, so right there, it has to be T alpha over 2, comma, the degrees of freedom. The area below the critical value is 0.025. So earlier, beginning of the semester, I mentioned there is a reason as to why we write the notation this way. This sort of tells us what we need to put in a calculator or in any type of technology to find the critical value. So the T would stand for inverse T, 0.025, 11. That is going to give us the negative critical value. If you plug in 0.975, 11, you get the positive critical value. Yes. Go ahead and plug that in and tell me what you get.
You said for a positive critical value, is it 0.75 you said?
97.
97, okay.
Should we put this in the calculator? What do you get, Judith?
Negative 2.2010.
To be precise, I'm going to write the critical value as positive critical value. Now, of course, we can use the negative critical value, then you have to do some algebra to understand it. But if you always use the positive critical value, you don't have to think further. You can directly plug this in the formula. So now we have the value of the standard error. We have the critical value. If the negative side is negative 2.201, what would the positive side be equal to? 2.201. So the critical value is 2.201 multiplied by the standard error, which is 0.471. And what do we get? Point 8, no, 0.9496. Probably 0.96.
At 1.036.
1.036. So the margin of error is 1.04. And we're trying to find a confidence interval for difference in means. So we need to know the difference in the sample means. So the difference in sample means, which is x1 bar minus x2 bar, is 19.07 minus 20.42. Negative 1.35. Don't think we need this. I'm going to erase this part. The 95% confidence interval for the difference in means, by means I actually refer to population means. Which is simply mu1 minus mu2. And how do we find that interval? We make use of the sample mean difference, which is x1 bar minus x2 bar. So x1 bar minus x2 bar minus the margin of error, x1 bar minus x2 bar plus the margin of error. So this is going to give us the lower endpoint, and that will give us the upper endpoint. we know the difference, which is negative 1.35. The margin of error is 1.04, so I subtract the margin of error. And negative 1.35 plus 1.04, because the margin of error is E, so I'm adding plus 1.04. So what do we get here? This would be negative 2.39. Did we get that interval?
What does it say at the bottom?
Negative 2.39 less than mu1 minus mu2, which is less than minus 0.3.
Okay. Did you say 0.31 is the last number? Okay, thanks.
But the negative, it's negative 0.3. Can I erase this now? Yes.
I have a question, for the margin of error, how would you find the critical value for a left-hand test?
This is not a test.
Okay,
This is an interval.
okay,
So it's always, two-tailed. You always divide it by two.
okay.
Because you have a lower endpoint, you have an upper endpoint. So that's a good question. A test is not the same as an interval. But could I come to a conclusion using an interval? What are the conclusions that a test might give you? Absolutely. And that's exactly what I'm going to do next. Can't erase this. So the interpretation would be with 95% confidence we conclude that the difference in means, that is mu1 minus mu2, or the average of sophomores minus the average age of juniors is going to lie between negative 2.39 and negative 0.31. Let me ask you this. Would you say that with 95% certainty that the difference is going to fall between those two values? In other words, is this the end? Is this written in stone? Lauren says no, Chanel says no. Why?
Because there's still 5% chance.
There is a possibility for 5% error. In addition, we only base it on one sample or two samples that we collected. So a more formal interpretation would be that is more formal. If I resample the population 100 times, 95 out of those 100 times, the difference in means, mu1 minus mu2, will fall in the interval that we just found. Does that make sense? Yes? sequence. Well, let's start with the second question. What test would you perform to answer that? Is the average mean of sophomores the same as the average mean of juniors? What test should you perform? What hypothesis test should you perform? We have three options. You could either do a left-tail test, a right-tail test, or a two-tailed test. Which one should you do? Huh?
Two-tailed?
Two-tailed. I do have to point out that we haven't done a two-tailed test for difference in means yet. It's coming later on. So if we were to perform a test, it would be a two-tailed test. But now that we have an interval here, I don't even need that test. I can sort of explain or answer that question using the interval that I have. So using the interval, the average age of sophomores, we call it as mu s, the same as mu1. Average age of juniors is mu sub j, which is the same as mu2. Would someone want to disagree with my statement that 0 does not fall in the interval that we obtained for the difference? Does 0 fall here? No, absolutely not. Because the interval is from negative 2.39 all the way up to negative 0.31. 0 clearly doesn't fall in the interval, so our conclusion is that they are not the same. The average age of sophomores is not the same as the average age of juniors. Does that make sense? Okay. Now that we've answered that question, So, is the average, we've already agreed over there that the average age of sophomores is not the same as the average age of juniors, which would simply imply that it should either be greater than or less than. Are you with me? Because they're not the same. If that is the case, do you believe that the average age of sophomores is greater than the average age of juniors, or less than the average age of juniors?
Less.
Why?
Sophomores are younger.
Huh?
Sophomores are younger.
How do you know?
Well, our sample
Evidence, right?
in our sample statistics, X bar 1 was 19.08, and that was the average age for sophomores. And then X bar 2 was 20.42, which was the average age for juniors.
So you go back and look at the sample information that we had. Clearly we have established that they are not the same. So if you go back and look at the sample, sophomore age was 19.47, yes,
Oh, yeah.
08, and the junior age was 20.42. So clearly the average age of sophomores is less than the average age of juniors. The mean that we had for sophomores was 19.08. And for juniors, 20.42. So you can conclude that using that approach. Or you can look at this. The interval, the entire interval is shifted to the left, right? In other words, could, by any possibility, mu1 minus mu2 be greater than 0? No. We have concluded that the difference has to be less than 0 because this is negative, that is negative, so it cannot take negative values. So from the interval, mu1 minus mu2 is the same as mu s minus mu j is less than 0. And we could write this because 0 does not fall in the interval. Do you agree? If we did some algebra, what would we get? If I move mu2 to the other side, same conclusion, yes? So you can either infer it once you're done with the interval, that 0 doesn't lie in the interval, so you go back and look at the sample information to conclude, you know, what it's likely to be. So, or you can use the interval itself, and since no positive values are feasible, 0 is not feasible, so I can conclude that. And if you rearrange it, you end up getting mu1 is less than 2. Good? This is a side note for the future. When we do a hypothesis test, you can connect the dots. So, if this were to be the claim, hypothetically, mu1 is less than mu2. It is equivalent to saying mu1 minus mu2 is less than 0. Yes. So what test should we use to verify that claim? Right tail, left tail, good tail?
Left.
Left tail. If we perform a left tail test to verify mu1 minus mu2 is less than 0, what would the conclusion be? Would you reject the null or would you not reject the null? Let's start with this. In our usual definition, is mu1 minus mu2 less than 0 the null or the alternative? The alternative, right? No equal sign. So if I perform a left tail test to verify this claim, would I reject the null or would I not reject the null? We will reject the null. If I reject the null, I'm finding evidence toward mu1 minus mu2 less than 0. Do you see how an interval and a test are one and the same, but interpreted differently? Now you may ask me, well, if the interval can do all this, why can't we just stick with one or the other? It's because of the final information that we get. When we perform a test, we can conclude whether to reject or not reject using the p-value. So that sort of tells us the significance. In other words, it quantifies. Earlier I wrote if we did 100 times, 95 out of those 100 times, the difference would fall in that interval. A p-value is going to give you an exact number. It's not going to be 5%, it will tell you the exact probability, maybe 2.5% of the time. So all 3 times out of those 100, it will fall outside of the 2 intervals, 2 endpoints, or 97% of the time, it is going to fall between the 2 values of the interval. This is used more for a practical purpose or a scientific purpose. So oftentimes in practice, when you perform a test, you would automatically get an interval also. So if someone asked you, well, how many years do you think the difference is approximately? You could say a maximum of 2.39, right? In other words, mu s minus mu j is less than 2.39. So practically, I could conclude mu1 minus mu2 is 2.39. Greater than negative 2.39. Yes? Which would mean mu1 is greater than mu2 minus 2.39. Yes? If someone asked you, well, can you quantify and give me an exact number that is likely to compare the difference, I could simply say the average age of sophomores, exactly that right? Yes, it is greater than the average age of juniors, but the difference would be negative 2.39. So whatever value you have for juniors, you have to subtract 2.39 from it. Does that make sense? So if mu2 is 20 years, then mu1 would be less than 20 by negative 2.39 years. So it's about 18. If mu2 is 22 years, so you have to subtract it by negative 2.39. So that would be about 19.61. Does that make sense? So the interval is used for more numerical quantification. A test is a formal way to conclude and give that probability of us being wrong exactly in making a conclusion. An interval always assumes, okay, there's a 5% chance that we could be wrong, as Lauren mentioned. But if you do the test, we will know, oh, it's probably less than 5%, because the p-value could be 0.0294, which means 2.9%. Does that make sense? Okay. Any questions? Anything we did? No? I'll start this, but we will pick it up next time because I want to talk a bit about the exam. So yes.
I have a question about the exam. For the homework, it had us for homework number 4, I think it had us use standard deviation squared instead of square rooting the number that it gave us for variance. On the exam, are we gonna have to square root the
Yeah.
number for variance?
It depends on the question.
Okay.
So there is a thing called pooled variance, and a pooled variance is when you take two variances and put them together, just like carpooling, you kind of put things together. This is not the best choice because the assumption here The assumption here is that the population variances are identical or almost identical. But here's the catch. We don't know much about the population, so how could we make any sort of conclusion about the variances being identical? Do you see that logical issue here? In rare cases, when we do an experiment or a study, we actually know that the variances are quite identical and we can proceed. But in practice, it is not recommended because this particular violation will be, this particular assumption is more likely to be violated, which is why it's not the best choice. What is the change? None of the things that we performed here will change. Whatever I did since the beginning of class, it's the same. The only difference here is the standard error. The standard error is no longer what I had s1 squared over n1 plus s2 squared over n2, then take the square root. Here it is simply sb multiplied by square root of 1 over n1 plus 1 over n2. Any guesses as to what SB could stand for? The hint is in the title up there. What would SB squared stand for? Sort of is related to
The pooled variance?
SB squared is the pooled variance.
What is SE?
Pooled variance.
No, SE.
Well, you tell me. If SB squared is pooled variance, then what is SB?
Pooled standard deviation.
It is the pooled standard deviation because the square root of variance is the standard deviation. So the entire process is the same, only that the difference, or one of the two differences, is that the standard error has a different formula. In addition, the distribution here it is still t, but the degrees of freedom is no longer the minimum of n1 minus 1 and n2 minus 1, rather it is n1 plus n2 minus 2. Yes,
What is it over?
this one?
Yeah.
n1 plus n2 minus 2. It is the same as the degrees of freedom. Good. So, not next time we have the exam, but on Tuesday we will do an example on this. Good. I'll quickly go over the exam and address questions if you have any. Going to erase this side. So there are 16 questions. The last question is optional, and it is a 5-point extra credit. If you get it right, if you get it wrong, it is not going to affect you negatively. It is optional. By all means, you could say, I don't need the credit. I can make 100 without it. Go for it. Things to know in section 9.1, which I believe is basics of hypothesis testing. What should we know? Well, we should know how to identify the null and the alternative for a given scenario. Reject null or do not reject null type of conclusion. Now mind you, I picked all the questions from the textbook's test bank. So if you did the homework well, and if you understood the homework, then the test should be a breeze. If you didn't understand it, then it's a problem. Good, because every single question came from the textbook. Or would come from. 9.2, we skipped 9.3. Hypothesis test for me, which is our usual t-test. Certain things that you've got to know is finding critical values and peak values. Without a sample. What do I mean by that? I've looked at the homework, so there are some problems in the homework where they don't give you the sample, they don't give you anything, but they simply say, oh, alpha is 0.1 and the test statistic is 2.43. What is the p-value for this test? So there are problems like that. So problems of that type. If the data is provided, how do you perform a t-test? Or what do you use to perform a t-test? If a sample is given to you. How did you guys do it in the homework?
You have the mean and average, and you have the test statistic, like null that you're trying to test, and then you use the square root of the sample size over standard deviation.
Standard deviation over the square root. But what is an easy approach? Easy peasy, English way of saying it, EZ.
Just be using the calculator?
Louder, Kate.
Oh, use the calculator.
You use the calculator. What function in the calculator?
1 course. Is it?
Chanel?
What, for a t-test?
Yeah.
What if you just go to statistics and test?
So go to start, go to test, and pick t-test, right? Okay. I might have the sections backwards, but put the title correctly. So hypothesis test for proportion naturally that is going to use a normal distribution, and in the calculator, what would you use? Common mistake. People would go for the z-test, which is option number 1. You cannot use that. Why? This is a test for proportion, so what should we use?
The one prop.
The one prop z-test. Now make sure that you put the formulas also, because there are problems in the homework where they just ask you to use the formula to get a test statistic. And if there is something like that on the exam, I want you to know the formula. Should you memorize the formulas? No. What should you do with the formulas?
Put them on the cheat sheet.
Write down on your cheat sheet. How many do you get to have?
3.
3. One-sided or two sides? 2 sides. If you have that quick study guide that you purchased from the bookstore, read through it and understand where things are. So that is the purpose of writing a cheat sheet or going through a study guide. This was Lauren's question. Some of the problems would have, tests for variance. Some would be tests for standard deviation. But keep in mind, you're simply testing for the standard deviation. But if the problem states the test for variance, you simply do the same test and make use of the standard deviation by taking the square root of variance. Does that make sense? So it is the same test. What do we use in the calculator?
The chi-square test.
Chi-square test. The calculator does not have a function called chi-square test.
Oh, the chi-squared C,
So there is a chi-square test, and there is chi-squared G of F test, G of F test. We will do that later on, but you cannot use those two options for this particular test. Those two are meant for something else. We will cover that later on. So this has to be done manually, so make sure you understand the process thoroughly. If you don't have a table, what do? Excuse me, what do we need for this test? The table, right? The table is Appendix A4. It should say chi-square table. So make sure you bring the chi-square table. The chi-square table is not part of your cheat sheet count, as long as you don't have anything written on it. Gina?
For the cheat sheets, like, what exactly are we allowed to have on there? Like, can we have like our notes, like stuff from
You
our
can put
notes?
anything you want.
Okay.
Put a picture of your cat if it's going to make you happy.
Where do you find it again? I didn't hear. This appendix? Where did you find the?
The ebook. So if you go to the ebook, click table of contents. In the appendix, it's table A4, and it will let you print directly from the site. It does it?
Oh, no, I had to make an Excel spreadsheet myself and then print it.
Just use snipping tool.
Yeah, or use
For the
snipping
screen.
tool. If it doesn't,
You can just Google it and download it.
Sloan said you can just Google it and download it. Keep in mind, those tables are defined in different ways. Some books would use area in the right tail, some would use area in the left. The structure of the table would be different. If you are completely thorough in the process and how to determine the areas, then do what Sloan did or is planning to do. Print any table from Google and you should be okay. If not, I know for a fact that you should be able to print it
There is
directly.
a printer icon, if you click it, it
Yeah.
brings up options, either save as PDF on computer,
Right.
send to printer, or a couple of different other things.
Yeah, I tried that, but it's still spread it out like across several different pages.
Oh, I just printed it as it was, it gave me like 3 sheets of paper, but I figure I'll use it how it is.
Yeah, you can just select one page and print it.
I found it easier to just make an Excel document.
Got it.
So if I recall correctly, you can just click the table A4 and then an icon would pop up on the side somewhere that says print and you click on that and say it's PDF.
In your class, there you said something that, you look at appendix 8, the piece of it. Something about printing
No,
out.
I can't hear you.
You also said something about printing out a table from appendix 8. And
The T table.
Yeah.
So the T table is required if you do not have inverse T on your calculator. So some of the TI-84 calculators, the older ones, do not have inverse T. TI-83 definitely doesn't have inverse T. Who's got TI-83? So make sure you guys print T table. So you have to print both T as well as chi-square. Go to the usual spot where we look at the distribution and inverse functions. And if you don't see inverse T, print the table. Good? Before we end, an important note so that you don't mess up. Critical values are found using INV functions, in other words, inverse functions. Whereas, p-values are found using
CDF.
CDF. So anything INV you see in the calculator, you are going to use that to find a critical value. If you see a CDF, it is meant to compute a p-value. Are we good? Solid? How many of you plan on making an A? Very good. Others, try. If you have any questions, talk to me. If not, I will see you on Thursday.
I love the number.